Okay, so let's start with a couple of proofs and let's do forward proofs. All right? Not as complicated as the last one we did involving the odds or the prime numbers. So let's say if k is an odd integer, and m is an even okay. So unlike the previous problem where we did the method of exhaustion, this one's actually true and we're gonna prove it to be true. So what is meant by this? We say m is odd. So if m is odd, okay, and m is even, so that would be some 2b Okay, so this is basically our if statement right here. I'm just saying, this guy's odd, this guy's even. That's it. Meaning there has to exist an integer such that's 2a, that k equals 2a plus 1. Okay, that's just going back to the definitions that we did at the beginning of class today. We need to define what it is to be odd and what it is to be even. So then we can say, all right, now what I want to do is I've got my if statement. Now I want to prove this statement right here. Okay? I want to say then k squared plus m squared is going to be odd. Okay? So my question becomes about, instead of just k m, we are going to ask about k squared plus m squared. And we want to justify that this is actually odd. Okay? So we go back to our if statement, and we're going to plug our if statement into this and manipulate it to try to determine if this one really is odd. Okay? So that would equal 2a plus 1 squared, and then plus now 2b squared. So we're just basically plugging in that one is odd and one is even. Okay? Okay. So that would give me 2a times 2a, yeah, plus 1 . And if we do a little bit of manipulation of this, Okay, so just for the definition of what it means to be, oh, sorry, tilted. Okay? Therefore, it is off. Because 2 times an integer plus 1 is the definition of what it means to be odd.